Hey everyone. Okay, so I'm going to orient you on the Kidsights data platform repository. This repository has a series of pipelines that are in development or already in production. You can get to the repository from github.com/Marcus-Waldman /Kidsights data platform. Uh, to orient you, I've created a web page for the Kidsights data platform that has a 5-minute orientation. To get to that, you would go to marcus-waldman.github.io /Kidsights data platform. I highly recommend that if you are going to work with this platform, that you do so in Claude. In fact, in Claude, you can point it to a repository, and then you can point it to this Claude Markdown file, which is at the directory root. What that Claude Markdown file is a series of instructions in order to help give Claude the context in order to answer questions. So even if you don't plan on coding with Claude Code, I still recommend that you use Claude to basically act as a chat box to answer your questions about what this data platform is, because there's a lot to it, and I'm just going to point out the essentials here. So what it is it has independent pipelines. Right now, there are 7 that are active, and I'll talk about the 8th at the very end. So, for example, we had the Nebraska 25 pipeline, which ingested the REDCap data, did the transformations, developed the weights, all that kind of stuff. Currently, we are working on the Minnesota 2026 pipeline, and that's going to be where most of the attention is going to be paid in order to get that data ready in the next few months. So I have already posted my slides that I'm going to present to to Daisy and her student, but I've created a thorough guide as well, and you can click on those from this card, so this Minute 2026 card, in order to get started on that specific pipeline. We also have a American Community Service, NHIS, NSCH, raking weights, and imputation pipeline. None of those, the imputation pipeline might be relevant down the road. The government data sets and the raking targets, they're all for raking, which was relevant for the Nebraska 2025, but not for 2026. So fundamental to this platform is this database. It's a DuckDB database. And that database is gonna hold all analytical and intermediate and raw data sets. And the way that it works is that you will get a source data set, so like a raw data set, so that might come from REDCap, or might come from ACS or NHIS or the NSCH. It'll do a bunch of transformations on that data set in order to do variable recoding. It'll create scores, it'll do imputation, all that stuff will happen in R. But then it needs to get uploaded to the DuckDB database. And I found the most reliable way to actually do that is through Python. So it creates a feathered data set, a temporary feathered data set that's stored on the hard drive, the local hard drive. And then it's through Python writes to the DuckDB database from that feathered data set. And there are also codes that are code that can read from that DuckDB dataset. So you don't need to go through Python to get back to R. You can actually just read it directly from R. But for some reason, the writing was most reliable going through Python here. Again, so that database is going to contain lots of different tables. Currently, there are 97, again, raw, intermediate, and analytic tables. You can find a full catalog of the tables by clicking on this link, this full table catalog. As you, if you're going to really dive into this database, I've created this handoff markdown file, which will give you, well, we could just click on it here. It's going to give you instructions on what you should read first, what's running in production, active work, that kind of stuff. Um, and again, this Claude Markdown file, you're going to want to know how to install the data platform on your machine. So that will require things like R, Python, DuckDB, an environment file, and API keys. And that installation guide is provided here if you click on that card. And then there's just a quick reference and per pipeline documentation. Again, I've tried to document every single pipeline fairly thoroughly. And so that's available by clicking on that card. So one of the advantages of Claude is you can develop skills. And those skills basically are shortcut ways of making sure things that routine scripts can be done in an automated fashion. So like the most relevant one, for example, is as you add tables, you'd want to refresh the database inventory. And so there's this skill refresh database inventory that can be used by Claude in order to Claude Code in order to refresh this tables markdown file. Again, that tables markdown file is going to have a list of every single table, how many rows, how many columns, and kind of a description where it came from and that kind of thing. Okay. All right. So the other thing is Abby asked about the NE25, the NE25 weights. So one of the things that I did was construct weights in 2025, but I didn't construct replicate weights for accurate variance estimates. I have subsequently done that. Now, you first thing you're going to want to know is like what might be the mathematics behind it. There is a Quarto Markdown file in the repository that will go through the mathematics behind how those weights were constructed. And then we have the Bayesian bootstrap. So all of that technical detail is there. So we don't have a 2026 imputation. There was an IRT calibration pipeline, but that's actually deprecated. I never got that really as a full pipeline. It was just manual from the last time. And so the only thing I noticed is that might be some inconsistencies in the way that the NSCH table names are named, but not a big deal because in the 2026 it's not going to make a big difference. Um, but just be aware if you ever need to download those data tables, that might be something that comes up in terms of an incompatibility. Um, and again, I'll just talk about the things that you need to be familiar with. So one is R. Here are the packages that you would need. Another is Python with the packages that you would need. And for just running the pipeline, I don't anticipate that you would actually need to know Python fluently because the code is pretty unstandardized. The R code, however, is something that might require individual tweaking. The DuckDB database, so this is going to live locally on your computer. And it's not committed. So this is not actually going to show up in the Git repository. So I'll have to share that. But it's in the data folder, DuckDB, and then Kidsights local DuckDB. I've put a legacy copy up on the OneDrive, but I like working with local copies until I absolutely need to put it up on OneDrive. Just to avoid any kind of conflicts with syncing. And then M plus, if you're going to do any psychometric IRT calibration, that's what I used. And then we have Apache Arrow Feather. You don't really need to know that in detail. Just know that it's a way of, uh, it's like any kind of data file. And then we do use Command Stand R in order to do the replicate weights, but that's not really relevant for what you're doing. Um, so again, just a local installation. You can go through this installation guide in order to install it on your machine. I hope that's helpful. Thank you.